In section 2.7, we're going to work on solving rational equations. A rational equation has an equal sign, and it joins some rational expressions in a statement that can be proven true by finding a value of x. Remember that a rational expression is a fraction with a variable in the denominator. So a rational expression has a variable in the denominator. As I look at letter A, the first thing that comes to mind is this x squared plus 3x minus 10, and the fact that it could probably be factored. So when I see negative 10 and 3, I think, 5 times negative 2 would give me negative 10. 5 plus negative 2 would give me 3. So I'm going to rewrite this quadratic as x plus 5 and x minus 2. Now here, a common denominator of all three of these rational expressions would be x plus 5 times x minus 2. So in this first rational expression, it needs the x minus 2 part. So I'm going to multiply by a name of 1, x minus 2 over x minus 2. The second rational expression needs the x plus 5. So I'm going to multiply the top and the bottom by x plus 5. So now I have 3x times x minus 2 plus 1 times x plus 5 all over x minus 2 times x plus 5 is equal to 7 over x plus 5 times x minus 2. Now that I have the same common denominator, I'm just going to disregard the denominator altogether. So I'm going to forget about this and I'm going to forget about that. Now, why does it work that way? Well, we're going to take a little side trip over here. If I said 2x over 5 is equal to 4 over 10, I could solve for x using like proportions. So I'd say 2x times 10 is equal to 5 times 4. And then 20x is equal to 20, x is equal to 1. Another thing I could do is I could have gone back to the original I'm going to go back to the original function or rational equation technically. I'm going to turn this into 4x over 10. Then I can just disregard these x's, solve for x, x is equal to 1. Now, why can I just disregard those 10s? Well, thinking back to thinking of it as a proportion. So you're going to cross multiply, 4x times 10 is equal to 4 times 10. Divide both sides by 10 and the 10s go away. So I've just kind of done a whole bunch of like reasoning through why I can disregard the denominator. If you don't believe me, keep working on your fraction work, and eventually I think it'll kind of be a light bulb moment like, oh yeah, they're just going to eventually cancel out if I treat it as a proportion. So I'm going to erase this. This was just for the fun of it. Now, what are we left with? So where did we leave off here? It looks like we have 3x squared minus 6x plus 1x plus 5 is equal to 7. 3x squared minus 5x minus 2 is equal to 0. I combined my like terms and I subtracted 7 on both sides to get the equation set equal to 0. Now I can factor. I can factor like so. If I went with a 2 here and a 1 there, negative 6x plus 1x would give me negative 5x. Or if you'd like to do master primes, 6x squared on top, negative 6x squared. You slide the first and the last together, drop down your middle term. Let's see, I could go negative 6x plus 1x, drop down, whoops, that should be a negative 2. Negative 2 goes first, 3x squared goes last, factor by grouping, and you're going to get down to 3x plus 1 and x minus 2. Okay, final answer here. X equals negative 1/3 and x is equal to 2. Before you step away from this problem, go back to the original function. Go back to the original function, and I see that if I were to plug in a 2 right here, I'd be dividing by 0, which is a no. X plus 2 is actually an extraneous solution. So before you step away from the problem, check to make sure you're not making any no-nos. All right, let's take a look at letter B. So we're going to practice just solving those rational expressions like we did in letter A. We're going to spend a whole lot of time on those in the next class period. But I'd like to spend the rest of this video talking through some applications, B and C. So it says find the dimensions of a rectangle with a minimum perimeter. So in other words, we want to minimize the perimeter. We're told that the area of a rectangle is equal to 200 square meters. Well, when I think about a perimeter of a rectangle and its area, I know that I need to consider its dimensions, which are just a length and a width. So area is 200. I can rewrite this in terms of how you find the area, width times length. And then perimeter wants to be minimized. What do I know about perimeter? It's going to be 2 widths plus 2 lengths. And we want the lowest possible, well, why did I put a W there? 2W plus 2L. We want the smallest possible value. Okay, well, I don't know. I have 2 equations, but technically 3 variables because I don't know the perimeter. So what I'm going to do is I'm going to say the length is technically 200 divided by the width. And then I can substitute that in right here. 200 divided by the width. And then now I have an equation for perimeter. If I plug this into my graphing calculator, I'm going to turn my calculator on. I can look for some zeros. Well, actually, I don't know what it's going to look like. Let's take a look. I'm pulling up my calculator. Clear y equals, I'm going to clear out these from a day ago or so, 2x plus, I'm going to call this 400 divided by x. Let's take a look at the standard viewing window, zoom 6. I don't really see anything. Let's change my window. In terms of x, I can go from 0 to maybe 25. I don't want to consider any negative values of x or any negative values of y because I know that lengths, area, perimeter, none of that junk can be, none of that stuff can be negative. And then my maximum, I'm going to say 250. My maximum area was 200. I don't know, maybe that's too much. Oh, okay. Well, this is what this looks like. Interesting. And it does look like I'm going to have a minimum value somewhere in here. So if I go second trace opens up the calculate menu and I can calculate the minimum point. So I'm going to choose 3. Follow the prompts at the bottom. I need to set my boundaries. Well, my minimum is going to happen, like I said, somewhere in here. So somewhere between there and then where this function appears to be kind of like on the increase again. I'm watching my y values. They're continuing to drop, 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 but they're getting bigger now. See how my y values are increasing? So I'll set my right boundary over there. Enter through the guess. So my minimum value happens right here at 14 point, what was that? 14.142, comma 56.569. So this was my minimum. So in other words, W is equal to 14.142, and this would be in meters. So the dimensions of the rectangle will be 14.142, and then what would the length be? I also need to know the length. So to find the length, remember that the length is equal to 200 divided by the width. So 14.142, 200 divided by 14.142. Let's just calculate that. And that'll give us our other dimension. And that would be, oh, okay, 14.142 again. So I guess this is a special rectangle that's technically a square. Interesting. Good stuff. All right, so then the final question is, what's the perimeter of this minimized rectangle? Well, the perimeter will be 2 lengths plus 2 widths. And this dimension will be something meters, M for meters. It came up with, oh, you know what, 56.569. Now, I just kind of had a oh yeah, oh, that's right moment right up here. This is going to be our minimum width, which minimizes, so to minimize the perimeter right here at 56.569 meters. So I guess I technically didn't need to do this, but oh well, it checks out. All right, then turn the page and let's talk about this can full of tomato juice. So what do we know? What's going to go on from here? So we know that the cannery packages tomato juice into 200-liter or 2-liter cylindrical cans. Now, liters is something volumetric. We're talking about something kind of linear, centimeters squared. So I'm going to turn liters into cubic centimeters. And the conversion factor there is 1 liter is 1,000 cubic centimeters. So what we want to know is the radius and the height if we know that the cans have a volume of 2,000 cubic centimeters and a surface area of 1,000 centimeters squared. So I'll go ahead and throw my labels on. So what do I know? With a cylinder, they have a circular base with a radius and then a certain height like so. So the volume of a cylinder is pi r squared, which is the area of the base, times the height. And more importantly, we can say that 2,000 is equal to pi r squared h. We're going to come back to that here in a minute. Now, surface area is equal to 2 times pi r squared, and these are the surface area of the bases, plus we also have the label. Now the label wraps around the can, and how far it wraps around is the circumference, or 2 pi r, and then so the 2 pi r would be like the length, and the width then would be the height. Surface area. Okay, more specifically, we know that the surface area is 1,000. So I can set 1,000 equal to 2 pi r squared plus 2 pi r h. So, well, I have 2 equations with 2 unknowns. So this is, just kind of an old-fashioned system. This is a beautiful system of equations, 2 equations, 2 unknowns. What can I do? What I'm going to do is rework this equation solved for h. h would be equal to 2,000 over pi r squared. I'm going to do the same thing here. h would be equal to 1,000 minus 2 pi r squared divided by 2 pi r. And then to solve for h, I'm just going to set, no, I take that back. I'm going to solve it for r. So to solve for r, I can set the h equal to the other h. Because no matter what, we're talking about the same can. The can has the same height and the same radius, whether you're talking about its volume or surface area. Okay, so check it out. 2,000 over pi r squared is equal to 1,000 minus 2 pi r squared over 2 pi r. So now to find the value of r, so to find r, let's set 0 equal to some expression, and then look at the graph. And the zeros will be our solutions for r. And I'm willing to bet we're going to have 2 because this r squared seems kind of quadratic. So I'm going to stop there, but I encourage you to kind of do the work to set this equation equal to 0. Plug it in your calculator and find the values of r. If you do that, send me a private message with the values of r, and I will give you some fat extra credit. All right? It's a deal. Go for it.